guys, I'm going to do this video to remind you of some things that we study about the atoms. So I'm going to explain the atomic number, the mass number, neutrons, protons, electrons, positive and negative ions, and isotopes. Remember that the different atoms that we have, or the different chemical elements, we can organize them in this table, which we call periodic table, okay? So I'm going to do the examples with the atoms of helium because are one of the smallest ones, so are going to be easier to draw. Okay, so if I want to draw one atom of helium, the atoms of helium have always two protons, okay? So I'm going to draw here two protons, and remember that protons are special because they have positive charge. And then surrounding the protons, I always have these particles that are called neutrons and that are special because they have zero charge. They don't have a negative or positive charge. And then on the outside, I'm going to have these particles here that remember that they are called electrons, and they also are special because they have a negative charge. Okay, and also these electrons are always spinning around the nucleus. They are always going around. They are moving in circles around the nucleus. Okay, and the nucleus is this middle part. Okay, the protons and the neutrons, they are together inside the nucleus. Okay, so let's see how can I know the charge of this chemical element? Okay, so I have to see how many protons do I have. How many protons do I have here? 1 and 2. So I have plus 2. Why plus? Because protons are positive, okay? And then minus 2. Why minus 2? Because I have 1 electron here and then 1 electron here. So if I add these two numbers, the total amount of this atom is going to have zero charge. Okay, so when it has zero charge, I'm only going to call this an atom of helium. How do I know again that this is a helium? Because I'm using here the example of helium that has an atomic number of 2. Okay, so let's review again what's the meaning of atomic number and mass number. Okay, so for helium has these two numbers, and I always write them like in the left part of the atom, okay? So this number here is the mass number, and the mass number is when I add the number of protons and the number of neutrons. And this number here is the atomic number, which is only the number of protons. So for this example here, I have to see, okay, how many protons do I have? 1 and 2. So I'm going to come here and see that, as you see, I have 2 protons. Okay, and again, if I have 2 protons, I have to see, okay, how many neutrons do I have? This one, 1, and this one here, 2. So 2 neutrons. And you see that this is why I can write here 4, because I have 2 protons plus 2 neutrons. And this is very important to know the meaning of mass number and the meaning of atomic number. Okay, so this is the most basic stuff that you need to know. Okay, so let's see now the difference between positive versus negative ions. Ions, I'm going to call them ions when I have either a positive charge or a negative charge. So for example, in this case, with the atom that we drew before, we said that it had a zero charge. It doesn't have a charge, neither positive or negative. So this is not going to be an ion because ions only have positive or negative charge. Okay, so let's see. Imagine again that I have inside one atom of helium 2 protons then 0 neutrons, and on the outside, only 1 electron. Okay, only 1 electron that it is spinning around the nucleus. So now if I want to see how much is the charge of this atom, I have to remember, okay, these ones are the protons and they have positive charge, and these ones are the electrons and they have negative charge. So how many protons do I have? 1, 2, so plus 2. And how many electrons? Only 1, so minus 1. Okay, so in this case, if I add these two numbers, I'm going to get the result of plus 1. So it is positive. So instead of calling this, like before, an atom of helium, I'm going to call this a positive ion of helium. A positive ion of helium. So imagine now that instead of having only 1 electron, I'm going to have now 3 electrons. So 1 here, another here, and then another on the outside here. So I have plus 2, because I have 2 protons, again, 2 protons, and I'm going to have minus 3, as I have 3 electrons. So the total charge of this is going to be minus 1. It is negative, so I'm going to call this negative ion of helium. Okay, so let's see now what are isotopes. You have to know that isotopes is all of the atoms that I have that have a different number of neutrons. This means that the number of protons and the number of neutrons is not the same. So in this example that I did here, I had 2 protons and 2 neutrons. I have the same number of protons and the same number of neutrons. So this is not an isotope. In this one, I also had 2 protons and 2 neutrons, so it is not an isotope. And also in this one, I had 2 protons and 2 neutrons, and this is not an isotope. So let's see now that I'm going to have now 2 protons in the middle, in the nucleus, but only 1 neutron, and again 2 electrons on the outside. You see that in this one, I have 2 protons, but only 1 neutron. So the number of protons and neutrons is not the same, so I'm going to call this an isotope, okay? This one is going to be an isotope of helium. And what happens if I have 3 neutrons? If I have 3 neutrons, it's also going to be an isotope of helium. If it has, let's say, 4 neutrons, it's also going to be an isotope of helium, because I have different amount of neutrons and different amount of protons. Okay, so how should I write this atom? Remember that if I want to write it like I did before, putting the name of helium here, and then in here I have to put the atomic number. Remember that the atomic number is the number of protons. So in this case, I'm going to have 2 protons, but then the number that I put in here is the mass number, and the mass number is protons plus neutrons. So in this case, I have 3. The mass number is 3 because I add the 2 protons with 1 neutron, okay? Okay, let's see now one exercise. Imagine that sometime they give me like this example and they ask me, in this atom of helium that we have here, how much is the charge? How many electrons do I have? Sometimes I can write electrons like this, okay? How many electrons, how many protons, how many neutrons do I have in this one? So let's see. It says that I have one atom of helium, It says that I have one atom of helium. If I go to the periodic table, I see that always helium has an atomic number of 2, okay? You see here that Helium has an atomic number of 2. Hydrogen 1, lithium 3, beryllium 4. So this atomic number, it changed. And remember that this atomic number, the atomic number, is the number of protons that they have. So always helium has 2 protons. So if I look in the periodic table and I see that always the helium has 2 protons, it is mandatory for me to know that helium has +2 because it always has 2 protons. But in here they are giving me this number. This number that they are giving me here is the total charge of this atom. Okay, so I don't know in this case how many electrons do I have, but I know that electrons are negative, so that's why I put minus here. And I know that the total amount of this atom is +2. So the total amount of charge is +2. So I have to think, how many electrons do I have here if I know that I have 2 protons and the total amount is +2? So this has to be 0. So in this case, I don't have any electrons. I have 0 electrons. Okay, let's see another example. Let's say that I have lithium -3. Okay, so how many electrons do I have in this case? How many electrons do I have? I need to go to the periodic table and see. Okay, lithium has an atomic number of 3. So it has an atomic number of 3. This means that it has 3 protons, like before, okay? 3 protons. I don't know how many electrons, that's why they're asking me, and I know that it has a charge of -3. So which number should I put here if I have +3 minus something and the result is -3? Okay, so the number that I need to put here is 6. As a +3 minus 6 is going to be -3. So I know that in this case I have 6 electrons. Nice is that if they give me this information, this is carbon, and they give me that the mass number is 12 and the mass number is 6. Okay, so if I go to the periodic table, I'm going to see that carbon, which is here, it has an atomic number of 6. Remember again that the atomic number is the number of protons. So if they give me this, they are telling me, okay, the atomic number is this one. So this means that I have 6 protons. And remember again that this number is the mass number, which is the number of protons plus the number of neutrons. So if I already know that I have 6 protons, because I see this number here, I know that I have 6 protons, and they are telling me that this number here is 12, this means that I need how many neutrons here? Also 6, because 6 plus 6 is going to be 12, which is the mass number. Okay. What about in this case? In this case, I also have 6 protons, but you see here that I have 13 as the mass number. This means that if I have 6 protons, I need how many neutrons? 7. As 6 plus 7 is going to be 13, which is the mass number, the number of protons plus neutrons. Okay, and in this final example, again, you have 6 protons, and then this number here is telling you that you have 6 protons plus 8 neutrons. Okay, so if I ask you, let's say, are these 2 atoms, are these 2 carbon 13 and carbon 14 a normal atom of carbon? And you have to tell me, no, it's not a normal atom. It is, those two are isotopes. How do we know that they are isotopes? Because the number of protons, it is not the same as the number of neutrons. So isotopes are going to have always the same atomic number, but different mass number. You see here that they have the same atomic number. They always have 6, and 6. The atomic number is the same, but the mass number is different because in this case you have 12, in this 13, and in this 14. Okay, so that's the end of the video, guys. I hope you learned something today. Bye.